Hi everyone, I am Dr. S. Satish, Assistant Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tirchanur. Today we are going to discuss about the topic in Applied Materials Technology. The topic is solid solutions. So this is an overview about the topics which we are going to discuss in the today's session. So first thing, in the solid solution, what is alloy? The thing, what is alloy, we are going to discuss. Then, what is solid solution? In the solid solution, what is solute? What is solvent? Then, what are the types of solid solutions? Then, we are going to discuss about substitutional solid solution, what it is. Then, we are going to discuss about the interstitial solid solution, and then what are the conditions that needs to be followed in order to attain the solid solutions. So these are all the things we are going to discuss in the today's session. So let me move on to the topic solid solution. So before going into the solid solution, we have to discuss about what is alloy. So generally we will hear that term alloy. So what is alloy? An alloy is composed of two or more chemical elements in which at least one of the element needs to be a metal. So the combination of one or two elements which will react together in order to obtain the material which is nothing but alloy. So in that, any one of the material needs to be a metal. So in these conditions we will get a alloy. Generally the addition of elements which will be called as impurity atoms, that is, the impurity atoms have been added intentionally in order to impart specific characteristics of the material, which is nothing but in the alloy we are adding one more element which is we call it as a impurity here, which supports in the process of material property enhancement. So hence it will be call it as a impurity atoms which will be intentionally added, which will be purposefully added in order to enhance the property of the material. So that's why it will be called as a intentionally added to impart the specific characteristics of the material. So before going to an alloy, how it is? So in the initial time period, the material will be extracted in the form of ore. Further, the ore will be processed in order to get the pure metals. So initially the pure metals will be subjected to the applications, various applications based upon the needs of us. So when you are being put into the application wise, the properties which will be required by the specific applications is not able to met by the pure metals. So in that conditions, in order to we are in the position to enhance the property of the material, which is nothing but the pure metal. So what are the possible things? So people will be analyzed and they have been found out a solution to create an alloying element, to create an alloy. So by the addition of another elements. So that in that case we have been obtained an alloy. So here we can see about initially we will get the pure metals. So in that pure metals we have been intentionally adding an alloying element which will be further results in the formation of alloys. So then the alloys will be categorized into two different basic forms. So how it will be categorized we will see here. So first one is solid solutions. So based upon the outcome of the alloy, it will be categorized into two things. One is solid solution and another one is intermetallic compounds. In the today's session, we are going to discuss about the solid solution. So solid solution, what is solid solution? Before going to discuss the solid solution, we have to look into the two terminologies. One is nothing but solvent and another one is solute. So what is solvent? So solvent is nothing but the major element. Let me take a simple example. We will take a simple example of dissolving salt in the water. So in such a case, here the water will be the solvent, which will be the major portion in that, and next one is the solute, which is the minor element, where in which we are going to add a salt. Another example, let me take we will have a habit of taking coffee or tea. In such a case, we will add a little bit of sugar. So in that tea or coffee, then we will have it. So the addition of sugar with the beverages, tea or coffee, whatever it is, so which is comes to a solid solution example. So in this case, the solvent, which is nothing but tea or coffee, and the sugar what we have been adding is nothing but your solute. So the major part is tea or coffee or water, whatever it is, and the minor part, which is the minor element, which will be the solute. In this case, we have been sugar or salt. So these two things will result in the formation of a solid solution. Similar to that, when we come into metals, we have been adding one metal into another metal, which results in the formation of alloys. So the major concentration of a metal, which will be comes under the category of solvent. The element which will be added at a least composition will be comes under the category of solute. So when the particular crystal structure of the solvent is maintained during the alloying process, then the alloy is called as a solid solution. That is, the crystal structure of the solvent material remains unchanged. So that conditions will result in the formation of solid solutions. So when, I will repeat it once, when the particular crystal structure of the solvent material is maintained during the alloying process, then the alloy is called as a solid solution, which means that the crystal structure of the solvent material remains unchanged. Then the crystal structure is maintained and no new structures are formed. This is only we have discussed right now. Then the solid solutions will be categorized into two types. One is substitution and another one is interstitial. So the solid solutions will have been two forms. One is substitutional solid solution and another one is interstitial solid solution. Let me see a picture. So now we can able to observe two images here. So here there will be a stacking of, that is an arrangement of balls. There will be two different forms of arrangement we can see here. The first image we can look into it. There are two different colors of balls here. The first one is the yellow color ball, blue color ball, and another one is green color ball. Here, and the next image, similar to that, there will be arrangement of balls here. In between the balls, there will be a blue color, smaller balls will be observed. So, what is the two, how we can able to differentiate these two images? In this case, we can see that the solvent is the major portion and solute is the minor portion. So, just to look into the image, the green color balls are found to be a major composition and blue color balls are seems to be a minor composition. So in here the green color balls are the solvent and the blue color balls are solute. So we will discuss this image in the forthcoming slides and we will categorize which one is substitution and which one is interstitial. So first, substitutional solid solutions. The size of the atom is similar to that of the solvent atom. So next one, solute atoms can replace solvent atom. So these are the 2 points. So next, the example for that, the substitutional solid solution, the one best example is brass, in which zinc and copper is the two compositions and copper is the solvent and zinc is the solute. So now the similar image what we have been seen in the previous slides. You can able to notify that the green color balls are the solvent, which is nothing but here copper, and the blue color balls are zinc atoms. That is that the balls are nothing but atoms. So the solute atoms replace the position of solvent atoms, which is nothing but it substitutes for that copper atom. That is, the zinc atom will be replaces in the position of solvent, that is copper atom. So which substitutes for an atom. So hence this is called as substitutional solid solution. That is, the size of the solute atom is similar to the size of the solvent atom. So once if you are going to substitute anything, so the size of the atom, it needs to be matches with the solute and solvent atom. In such a case only the substitution will take place. Hence the size of the atom is to be similar to that of the solvent atom. Then the solute atoms will replace the solvent atoms. So this is the this type of condition will be satisfied in order to form the substitutional solid solution. The best example is brass. So here zinc and copper will combine together to form the substitutional solid solution. Then there are two conditions that needs to be satisfied to form these substitutional solid solutions. These conditions will be formed by W. Hammond Rothery in the year 1899 to 1968. So this is known as Hume-Rothery rules. So let me discuss about what is the conditions. The two metals must have a similar crystal structure. So in order to obtain a solid solution under the substitutional category, the two metals what have been adding together will have a similar crystal structure. So next, the difference in the atomic radii should be less than 15%. That is the diameter of the atoms of the solute as well as the diameter of the atom of the solvent should not have a much difference. That is, the variations between the diameter of the atom should be within the range of 15%. So these conditions should be matched in order to get the substitutional solid solutions. Okay, in such a case there will be a question arises, if the two conditions may not be satisfied, what will happen? Yes, of course. So if the conditions are not satisfied, what will be happen? So complete solid solutions will not be obtained. So the process will not be resulted in the fully substitutional solid solutions. So another one is the amount of solid solution will be limited. That is, the formation of the solid solution will not be in the fully enhanced manner. So partial substitutional solid solution will be takes place. So these are the two conditions that needs to be satisfied in order to realize a substitutional solid solution. So next one is the interstitial solid solution. So in this case, each solute atom can occupy an interstitial position in order to form an interstitial solid solution. So another thing is the size of the solute atom is much smaller than the size of the solvent atom. So the best example for this interstitial solid solution is steel. So in this case, iron and carbon, these are all the two elements that will be mixed together in order to realize a solid solution. So here the carbon will be the solute atom and the iron will be the solvent atom. The atomic radius, that is the atomic radius of carbon will be 0.071 nanometer and the atomic radius of iron will be 0.124 nanometer. So you can able to observe the difference in the atomic radius. So in this case, what it will happen, the iron will replace, that is iron will be the solvent atom, in that carbon will be added as a solute. The atoms of carbon will be placed in between the atoms of the solvent, which is nothing but iron atoms. So let me see an image what we discussed in the previous slide. So now we can able to understand or observe how this interstitial solid solution will be formed. Let me take the example here. The green balls are the solvent atom, which is nothing but the iron, and the smaller balls, that is the blue color balls, will be the solute atom. So in this, the solvent atoms are arranged in the certain pattern. In that, the added carbon solute atom will be gets into the gap between these solvent atom. That is, in between the atoms of the solvent, the solute atoms will get in and it will be placed in that. So this condition of solid solution formation will be called it as interstitial solid solution, since the solute atoms will be get into the interstitial gap of the solvent atom. So we have been found that the atomic radius of the carbon atom as well as the atomic radius of the solute atom. So this is the condition that needs to be satisfied to form the interstitial solid solution. So as set of the similar conditions, here also there are two conditions that needs to be satisfied in order to realize the interstitial solid solution. The solvent atom must have more than one valence electron. So next one, the atomic radius of the solute atom must be less than 59% of the atomic radius of the solvent atom. So these two conditions needs to be satisfied in order to obtain the interstitial solid solution. So what will happen if these two conditions will not be satisfied? So as we discussed in the previous slides, if the condition is not satisfied, the one thing, the formation of interstitial solid solution may not be happens. And another one, in such a case it may forms, but the formation may not be realized in a full-fledged manner. That is a partial realization of interstitial solid solution may happen. So why this kind of alloying will be made? As discussed in the previous slides, in order to enhance the property of the pure metal to meet out the specific industrial needs, so we have been moving to the advanced manufacturing of material science. So this realizes the formation of alloys, that is the addition of another metals into a material, one more material. So this realizes the formation of alloys. Though the composition of the addition of alloying elements are very minimal, the properties of the material which will be realized, that is the formation of alloys, will exhibit a much difference between the property enhancement when compared to the pure metals. So hence there will be plenty of research will be made into that in order to realize a newer alloying material. So still now the research in the direction of development of newer alloying materials will be happens, and still plenty of alloy materials are being developed with the advanced, with the enhanced properties in order to meet out the present industrial needs. So thank you. We will discuss in the next session. Thank you.